So sex-linked chromosomes and sex-linked inheritance. Instead of thinking sex-linked, think X-linked. It's usually found on the X chromosome. A female has the sex chromosomes XX, and males have the sex chromosomes XY. In sex-linked inheritance, the genes are usually carried on the X chromosome. So sex-linked, X-linked. So the gene for color blindness is carried on the X chromosome and is recessive. So a person who has the trait, who is colorblind, must be homozygous. A man, Mitchell, has a colorblind daughter, and her genotype is X little b, X little b. See, the little b means it's recessive, she's homozygous for it, she has two of the same. Is Mitchell colorblind? Well, Mitchell's genotype, as we know, males are XY, and the allele will be carried on the X chromosome. So his daughter is going to get one X from her mother and one X from her father. So we know both of them are X little b recessive, so she's going to get that from Dad. So is Mitchell colorblind? Well, he only has one X, and that X has a little b. So yes, he is. So this next part tricked a few of you up. Must the fathers of all colorblind girls be colorblind as well? Why not? So, like we said, the girl gets an X from her mom and an X from her dad. So one X from her dad, the X little b, or the XD, or the X2, whatever the allele is, she has to get one from Dad. And since Dad only has one X in his genotype, it will have to have that allele, and therefore he'll have to be colorblind. So yes, the fathers of all colorblind girls will be colorblind as well. Now that doesn't mean that all fathers who are colorblind are going to have colorblind daughters. That just means that the fathers are going to give that recessive allele to their daughter, and that girl, could get a dominant allele, a big B, from their mother. Sorry if that looks confusing. So the girls could be heterozygous, have two different alleles, one from mom, one from dad. So the girls might not be colorblind, but if the girls are colorblind, then the father is as well. So using that same information, a man, Phil, whose parents could see color, marries a woman, Claire, with normal vision. One of their daughters, Haley, is colorblind, and her genotype, I don't know why I cut it off, will be XX. She is homozygous recessive. So we know that Phil is XY, he's a man, and he's going to have that little b. That one is from Dad, that one is from Mom. Claire, so we say Claire has normal vision, XX, because she's a female. We know a little b comes from Mom. But Claire can see, so she must be heterozygous. She has the dominant allele and she can see color. So Phil's father, what does he get from Phil's father's a man, so he's going to be XY. So he gets the Y from his dad. His dad can see color, so he's X big B. Phil's mother is going to be XX. She can also see color, so she's going to be X big B, X little b, so she's heterozygous. Two different alleles. Sorry about the poor handwriting. And moving on to part 3, a carrier is someone who does not show disease symptoms but can pass on the disease-causing alleles. This person is usually heterozygous for the trait. So in the case of Phil's family, his mother was a carrier. XX, she had the dominant allele, which means she could see color, but she also had the recessive allele that she passed on to her son. So she's heterozygous, because we know hetero means two different alleles. And she's a carrier because she carries that recessive allele, which she gives to her son, Phil. And Phil then gives it to his daughter, Haley. If you guys didn't notice, those characters are from Modern Family, one of the best sitcoms on TV, FYI. Now, X chromosome inactivation results in a patchwork of two types of cells in females, like calico cats, which is where they are like spotted with brown or black fur. Now this is because females have two X chromosomes, twice as many X chromosomes as males who are XY. They only have one X chromosome. And X chromosome inactivation prevents females from having twice as many gene products that are carried on the X chromosome. So the choice of which X chromosome will be inactivated is random. And this X chromosome inactivation happens in the embryo. So it's not likely going to happen once you're in middle age or a teenager. X chromosome inactivation is only when you're a fetus. So this last question was kind of like a critical thinking question. In sex-linked inheritance, genes are most likely located on the X chromosome. Knowing this, how might the X and Y chromosome differ physically? So the X chromosome is bigger. If you look at a karyotype, which shows all of the chromosomes in a cell, the X chromosome is significantly bigger than the Y chromosome. And so therefore, it carries more genes than the Y chromosome. A few of you asked, what is on the Y chromosome? Well, Ys are only in females, so how are males different than females? The genes on the Y chromosome code for proteins that help in the development of testicles. That's why females don't have the Y chromosome, they don't have testicles, they don't need those proteins, but males do. And that's all, almost all, that's on the Y chromosome. And then some other proteins, very small, while the X chromosome is bigger and it carries many more genes that are used both by